Alright, let's do a packet tracer demonstration. I'm using the new packet tracer 6.0 and I'm going to configure this simple network with IPv6 and get the hosts communicating with each other and configure the router's interfaces for IPv6. So first of all, let's demonstrate IPv6 with these PCs here. So if I click on PC1 and I'll go over here to the IP configuration window, and you can see now in Packet Tracer 6 we have the ability to configure IPv6 on our PC. Now by default the device already has a link local IPv6 address. You can tell it's a link local address by the fact that it starts with this FE80. Alright? And the rest of these numbers were actually generated from the device's MAC address. We can see this if we open up a command prompt. And you can see I've already put the command in. I'll just put it in one more time. ipconfig/all. And you can tell right here, physical address, there is the MAC address. And if you compare it with the link local address, you'll notice that the numbers are included in here. Notice BD-DADE, right? BD-DADE. Then in the center, to create the 64-bit interface ID portion of this address, the FFFE was inserted, and then the front half of the MAC address, 009021, is put in the front portion, except if you convert this portion to binary and you flip the 7th bit going from left to right, this 0 changes in the hex to a 2. So there's also a 7-bit switch that happens. The result is you've got the link local address that's been generated from the device's, let's say, MAC address. And that's what's happened in this case. That's what we see here, right? So the link local address allows the device to communicate on the local network. And any device on an IPv6 network needs to have, at a minimum, at least a link local address, right? So let's see if it works. And if it works, we should be able to copy this address, right? Copy. So I copy the link local address here. And if this works correctly, and this device has a link local address, and this device has a link local address, and they're connected to a switch, they should be able to communicate with each other on the local network using IPv6. And so I'll open up PC2, and in PC2 I'll go to the IP configuration window, and you see it has a link local address also. But I'm going to open up the command prompt, and right here at the command prompt I'm going to type ping and then a space, and then I'll right click and paste the IPv6 address of PC1. So now I'm trying to ping from PC2 to PC1, and let's see if it works. I'll hit enter, and you can see that in fact I'm getting replies, so that worked out. Alright, 4 echo requests, 4 echo replies using IPv6. So now that we've verified that we can communicate with the link local addresses on PC1 and PC2, let's bring up this router. Now the router will not have automatic link local addresses enabled, and in fact the router has IPv6 routing disabled by default. So we'll have to do some configurations on this router to get this router to play along in our IPv6 network. So I'll click on the router and I'll stretch this out so we can see it a little bit easier. Alright, and I'll type in no so that we can just go straight to a router prompt. I'll type enable to get to privileged user mode, and then conf-t to get to global configuration mode. Now in global configuration mode, the first thing that we're going to want to do is type IPv6 and then unicast-routing. If we do that, that enables IPv6 unicast routing on the router. So without it, IPv6 is basically disabled by default. So now that we have our IPv6 routing enabled, we need to go to our two interfaces, and we have interface gigabit 0/0, you can see it here, and we have interface gigabit 0/1. This router is the new 1941 router that you can use in the new Packet Tracer 6. So this is nice, a 1941 router. It has gigabit interfaces. So let's configure those with link local addresses. So I'll type interface, int, which is short for interface, G0/0, and that puts me into interface configuration mode. And I can type IPv6, and I can manually configure my link local address. Now with the PC, it automatically self-configured, and we could do this here if we wanted to, but in the curriculum, they recommend configuring a more simplistic link local address so that it's easier to remember and work with. Now, link local addresses are only locally significant, so you'll see what this can do. So we can say IPv6 address and then type in FE80 : and instead of putting in like a MAC address or doing an auto configuration, I'm just going to say : and then put in a 1, and then I can type in link. I'll hit the tab key, and you can see it finishes the command for me. So the full command is IPv6 address FE80 : 1 link-local, and this creates a manual link local address on the router. And in the curriculum, the 1 is significant, let's say, for just the fact that maybe it's easy to remember, or the fact that this might be router 1 or R1 in the curriculum. At the end, I'm going to need to type no shut for no shutdown. So now the interface is up, and it has a link local address of FE80 : 1, and that's much easier to remember because it's shortened, because all of the zeros in the IPv6 address can be abbreviated with just the double colon, right? So that looks pretty good. Let's do the same thing for the next address. So for the next interface, I can say interface gigabit 0/1, and I can do the same thing. And in fact, I can use the same link local address on the other interface. Since these link local addresses are only locally significant, they don't need to uniquely identify one network from another network. So I can just use the same address on the other interface, and that makes things even easier. So now both interfaces on the router have a link local address of FE80 : 1, and we can test it out by, you can see here that it's beginning to come up. The router's lights here on the interface ports are turning green, and the switch port is coming up. You can see it's orange. It was red, now it's orange. It's going to be green in a second. And I'll just go to PC1, open up the command prompt, and I'll type ping FE80 : 1. I'll hit enter, and you can see that we get a reply. So now we're able to communicate from the PC to the gateway using IPv6. If we go to the other router, we can also do it. So I mean, if we go to the other PC, PC0 here, which we haven't even talked about yet, we can also reach the gateway. We'll just go to PC0 here. You can see that by default, it has an IPv6 link local address, meaning we're ready to go. All we have to do is just ping the gateway, FE80 : 1, and you can see that we're getting replies. Now you might ask yourself, okay, so this is up, and this is up. Can PC0 ping PC1 with link local addresses across the router from this network to this network? Well, the answer to that would be no, because link local addresses are only significant on the local network. They're only used for communicating on a local network. They're not routable. So let's give that a try. So I'll go to PC1 again, and I'll grab that address. There it is. Right-click, copy. And just to prove that it won't work, got to test things out. Command prompt, ping, and we'll put it in here. And you can see that we're not going to get replies. We can't ping from one network to another network using a link local address. And you can see we've got requests timed out here. And that's not going to change. So I'm going to close the window. So in the next video, what we're going to do is, now that we've got our link local addresses correct, right? And this router has a link local address on each interface. So we'll just put that here. It's got a link local address here, and it has the same link local address on the other side. Now what we need to do is configure the devices with routable global unicast addresses. And so we need to configure the router with a routable global unicast address, and the PCs also need global unicast addresses, and so I'll do that in the next tutorial. Alright, so now that we have link local IPv6 addressing and we have IPv6 routing enabled on the router, and all these devices have link local addresses and the router has a link local address for each of its interfaces, we need to set up some global unicast addresses that are routable so that we can communicate from one network, or this subnet right here, to this other subnet right here. And to do this, we're going to have to create two IPv6 networks with separate addresses for each subnet. In the Cisco Academy, we use a global unicast address for these purposes that we can subnet, and this address is let's say, is in the range of routable IPv6 addresses, but it's been set aside for demonstration and for teaching purposes. So this address starts like this, 2001:DB8, and this is basically the internet registry part of the address. This is the internet registry prefix. And then let's say this is our ISP will give us our own prefix to identify, let's say, our company. And in the Academy, oftentimes it's used like this, a CAD, right? Or something like that. But in this case, we could just say like AAA, right? So 2001:DB8 AAA, which defines, let's say, the prefix for our company. And then in the next portion, we can put our subnet. So in this portion, we can put, let's say, 000A, and so this will be subnet A, let's say, and then I'll put : 1, and the 1 signifies that this is the first address or the first host in this subnet. So basically, if we were to write out this address in full 128-bit form, it would look something like this. So I'll put it down here just to give an example. All right, and this will be long form. So we would have a 0 here, actually, and then we'd have 1, 2, 3, 4, and then : 1, 2, 3, 4, and : 1, 2, 3, 4, and then 3 more zeros, and this would be the full address. And this is a 128-bit address, and if you divide it in half, you have 64 bits on either side. So the first 64 bits right here, and you can see this is in hexadecimal numbering, so it's actually 4 hextets. You can see 4 hex characters, 4 hex characters, 4 hex characters, and 4 hex characters, or 4 hextets. Now, we have this. This identifies the network prefix. This is essentially the network portion of the IPv6 address. You have the registry prefix here, and then you have the site prefix that's been assigned to you, let's say, by your ISP, and then you have the portion that you can create your subnets with. And all of this makes up the network portion. Now, the end portion, the last 64 bits, or 4 hextets, identify the interface ID, or you could call it also the host portion. This would be the host, identifying the host. In this case, it's called the interface ID, but it identifies the host on the network. And in this case, you can see we've got all zeros and then a 1, so this is the first host on the network. So this would be an appropriate address to give to the router interface, let's say, possibly. So we could put that right here. And when we condense this address or compress the address, we can get rid of the leading zeros. So we can get rid of all of the leading zeros. And then all of these remaining zeros can be expressed with just 2 colons. So I can delete all of those and just put in 2 colons, and then this is the address in compressed form. This is subnet A, and it's the first host in the address. All of the zeros have been omitted, and we're just left with : : 1. Now I'll select this, copy it, and paste it, and this will work also for the other network, except all I have to do is change the subnet to, let's say, the B subnet, or any other number that I want to use. So subnet A, subnet B, the first host address, the first address identifying the interface will go to the router, and all we need to do now is configure the router with this addressing. And one other thing before I forget, when we go to configure these global unicast addresses on the router, we're also going to need to include the slash for the network prefix. So in the address, it's the address and then /64, and the /64 identifies that the first 64 bits from left to right in the IPv6 address are for the network portion. So I'm going to put that in right here, /64, to let us know how long the network prefix is. In this case, it's 64 bits long to identify, or this long to identify the network prefix. And now we're ready to configure the router. So we'll go in the router, and we'll hit return to get started. Stretch this out again. Type enable. Conf T to get to global configuration mode. Interface G0/0 to get to gigabit 0/0. IPv6 address, and then I'll put it in 2001:DB8:A:1/64. All right, and that looks correct. If I can just double check that. Yes, that looks right. All right, I'll hit enter, and we have our address in there now. I'll put no shut again, although I don't need to do that. And then I'll go to the other interface, up arrow, and change that to a 1. Now I'm in interface gigabit 0/1. I'll up arrow again and just switch this over. Use the arrows on my keyboard and change that to a B. And now the second interface is configured. So now we've got global unicast addresses on each interface, right? I'll go over here to PC1, go to IP configuration, and to configure the global unicast address on the PC, we can use auto configuration or SLAC, stateless address auto configuration, and it will automatically contact the router, figure out what the subnet is, and then auto configure its own address and receive the gateway address from the router. So I'll just select auto configuration, and you can see, sure enough, it figured out that this subnet is the B subnet. It put in its SLAC, basically, which is a combination of the MAC address. You can see the FFFE inserted here, and it basically auto configured its own global unicast address by contacting the router and figuring out what the network prefix was. It also figured out that the IPv6 gateway, that the gateway is FE80::1. It got that also from the router. So that's awesome. So I'll just do that, and I'll get PC2 and do auto configuration here. All right, wonderful. And then on PC0, the same thing. Auto config. Let's see if it figures out. Yep, look, there's the A subnet. So PC0 is on the other network, and it auto configures. And all we need to do now is see if we can ping across the network. So to ping across the network, I can't seem to select this right here very easily. So what I'll do is so I'll grab the link local address, I'll copy that, okay? So I have the link local address copied from PC0. Now in PC1, I'll go to the command prompt, and I'll say ping. I'll put in the link local address, but then I'll change it to be the global unicast address. So 2001:. colon DB8 colon AAAA, right? Colon A, and then there is the IPv6 address. And now all we need to do is hit enter, and you can see that we're getting replies. So we were able to ping across from PC1 from this subnet, from this network, ping across the router to reach PC0 on the other subnet. Now, we did not have to add any static routes or any dynamic routing protocols to the router because it's only the router that we're going through. In other words, the router has one network on one interface and another network on the other interface, so the router knows about the two networks, and so we didn't have to configure any static routes or anything like that. We just needed to ping, and it works. So that is good news. We can also, let's just type it in, ping 2001 colon DB8 colon AAAA colon B colon 1, and we can ping our gateway. So PC1 is also able to ping itself, let's say, or not ping itself, but ping its gateway on its subnet. So that's pretty nice. Now, one thing I will warn you of, if your ping does not work, you need to make sure that when you select the PC, that the IPv6 gateway is still there. Sometimes I found that with the auto config, it will lose the gateway address. The IPv6 gateway address will sometimes not be there, and so then I'll have to go to static and then go back to auto config to make sure that that's still there. So you have to, if it doesn't work, check to make sure that, don't get frustrated, just double check to make sure that, see, you can see here it's disappeared, right? The gateway is lost. So just make sure that it's still there. Maybe don't even close the window here, just set it aside or minimize it, and then try your ping again, and it should work, right? You can see it should work. And if it doesn't, once again, double check to make sure that the auto configuration worked. All right, so that's IPv6. We're able to configure the entire thing with IPv6 addressing on all of our clients and on the router, and we were able to communicate from one network to another. Before I close out the video, let's take a quick peek at the configuration file inside of the router. So I'll hit enter, enable, and then do a show run, and we'll take a look at the configuration file. You can see up here in the running configuration, there is the host name, there's the IPv6 Unicast routing command that we put in, and then here's our interfaces. You can see here there's no IPv4 address on these interfaces right now. It's just IPv6, and we've got our link local address and we have our global unicast address, and we have both of those also on the other interface as well, and that was enabling the communication to work.
Okay, in this tutorial we're going to use Packet Tracer to create an IPv6 network and configure it with RIPng, or RIP Next Generation. It's an IPv6 routing protocol. Now this is for the Cisco CCNA 5.0 curriculum, and I created this Packet Tracer activity for just some practice at a first attempt at using a dynamic routing protocol with IPv6. So, and if you want to follow along and you're watching the video tutorial, you can download this Packet Tracer file that I created from my website at danscourses.com. You can see it here. It's called Packet Tracer 6 Activity, RIPng, and IPv6. And if you don't see it on the home page at danscourses.com, just go to CCNA 2 and you'll find it there. You'll see if I scroll down, it's right there. RIPng Packet Tracer 6 Activity. So this Packet Tracer activity is done in Packet Tracer 6. It's the new version of Packet Tracer, so you'll need that version to open the file. And once you open up this Packet Tracer activity, you'll see here it is. The instructions are on the main screen here where the topology is, and also there's an instruction sheet here which will give you some help too. As you work your way through the Packet Tracer activity, the completion percentage will go up. after every different activity or every different task that you complete in your configurations. So, and it pretty much lays out what you should do step by step. So you can see here, step 1, configure each PC with the 10th address in the IPv6 subnet, i.e. it's going to be a hex character A, because in hexadecimal 10 is an A. So that's what we're going to do. We're also going to need to give it a /64 network prefix length and the default gateway. And for the default gateway, we're going to be using the nearest router interface, and we'll use the link local address of the router. So let's get started and start doing this right away. So what I'll do is I'll close this window. You can see the instructions are right here as well. And we'll start with PC0 here. So PC0, you see we're going to give it the A address for the 10th address, and the subnet is 2001:DB8:DA:::1. That is the subnet that we're going to be working from. So, okay, so that's it. So this is the subnet right here, and we're going to be host A, and the router is going to be host 1. But if we look over here, we can see that the link local addressing for R1, this router, is FE80::1 on all of its interfaces. So we'll open up PC0 here, and we'll go to desktop and IP configuration, and we're going to do this with IPv6, and the address will be 2001. You can see here, there's the subnet, 2001:DA::1. That's actually the subnet portion of the IPv6 address. And then we'll say : for all zeros, and then A. So that will be the 10th address in the 2001:DB8:DA::1 subnet. The network prefix will be /64, and then the gateway address. Now, for the gateway address, it's said right here, okay, the default gateway using the router link local address. All right, so the router's link local address is FE80::1 for R1, and that's the router that we're going to be using as our gateway. So we put in FE80::1. And so there's our configurations for the first PC. Let's do the next PC. We'll go up here at the top. You can see there's PC2. It's also going to be :A. We need to know what is this network. And this network right here is 2001:DB8:DA::3 : /64. So, okay, so that's the network right there. The router is going to be :1 on its global address. On the link local address for the router, R2 will be FE80::2 on all of its interfaces. So we have all the information that essentially we need to configure this PC. So we'll open up the PC. We'll go to desktop IP configuration, and we'll put in the address right here, 2001:DB8:DA::3, because this is the third subnet, :A for the 10th host in the 3 subnet, or the 3 network. So there we go. We'll give it the /64 network prefix length, and then the gateway, which is FE80::3. So we've got the link local address. Actually, that's incorrect. It says here R2 is FE80::2, and it is R2 that we're going to be connecting to right here. So that actually needs to be a 2. The 3, I guess I was thinking about the 3 because the network is 2001:DB8:DA::3 and host A. So that looks good. So almost made a mistake, but I'm good. So I'll close that. And now let's go to this last PC down here, PC1. Also is going to be host 10 or :A, and the network is 2001:DB8:DA::5. So we'll open this up. We'll go to desktop. I'll drag this over a little bit and then click on IP configuration, and let's put in the address. So for the host address for this PC, it'll be 2001:DB8:DA::, this is the 5th subnet, :A, because host 10, and then the /64 network prefix, and then the gateway, which will be FE80::3. 3. And we know that because over here, link local addressing R3 FE80::3 on all of its interfaces. All right, so that's good. So we have that configured. So now all 3 of our PCs are configured, and we can now start configuring our routers with the addressing. And so we'll go to number 2 here. You can see here also there's a note on step 1 that says the link local address is already auto-configured on the PCs. What that means is that these PCs, when we first opened up the configuration, already had the link local address configured. That's because they're set to run the IPv6 protocol. So kind of like on my PC here on my Windows machine, if I look at my IP configuration, I'm running the IPv6 protocol, and so I'm given automatically a link local address. Every computer host on an IPv6 network needs at least a link local address. They'll probably need 2 addresses, a global unicast routable address and a link local address. So by default, just having the protocol on, you're given a link local address. All we needed to configure was our global unicast address, our routable one, our network prefix, and our gateway. And we could have been assigned those automatically. We could have selected auto config if our routers are set and running IPv6, and we could have pulled that address information from the routers. But in this case, we haven't even configured the routers yet. So that's why we just statically configured our addressing. Okay, so now that we have our PCs configured with IPv6 addressing, we can now focus on the routers. And you can see here in the instructions we're at number 2, and it says on all routers configure the following: the host name. And this includes the ISP router over here. So we'll have to configure host names on all the routers. We're going to need to enable IPv6 routing. We're going to have to configure all of the interfaces with the suggested IPv6 link local addresses and global unicast IPv6 addresses. And then it says see the topology diagram. So we'll look at the diagram to figure out the addressing. And then we have some serial interfaces here on the routers, and the DCE interfaces will need a clock rate of 128,000. So on R1, for instance, we'll do that one first. You can see that serial 0/0/0 points towards R2, and it has a clock on it. So that's our DCE interface right here on serial 0/0/0. Now, for our addressing, on R1, it's pretty easy. The link local addresses on all 3 interfaces, the gigabit interface and the 2 serials, it'll get an FE80::1 link local address on all of the interfaces. And you might ask yourself, how come you can put the same address on all 3 interfaces? Well, the link local address is only significant on the local link. So you can use the same address. They don't need to be unique on all 3. It just needs to be unique on that particular link or in that local network. So we can use ::1 basically on all 3 interfaces for the link local address. Now, the global unicast address is a little bit different. We're going to use :1 or host 1 for the LAN over here, and we're going to use the first address :1 for this network in between R1 and R2, and then for the network that goes in between R1 and the ISP router, the ISP is the first address :1, and R1 will be :2 will be the second address. And you can see these 3 networks, the network address is right here, and right here, and right here. So let's configure it and get started. So I'm going to click on R1. I'll stretch out the window so we can see the configurations nice and clearly. And I'll go to the command line interface, type enable to get to privileged user mode, and then conf T to get to global config mode. And we'll start by setting the host name to R1. So we have that finished. Now I'm in global configuration mode, and I'm also, once I've set the host name to R1, I need to enable the IPv6 routing protocol. So I'll type IPv6 UNI, and then I'll hit the tab key on my keyboard for command completion, and you can see it completes the command for me. So the command is IPv6 unicast-routing, and that enables the IPv6 routing protocol or IPv6 protocol on the router. And so now we can configure IPv6 addresses and the router will route IPv6. Okay, so now we need to configure our interfaces. We'll start with interface gigabit 0/0, and we'll start with, let's see, IPv6 address, and we'll start with the FE80::1 and then link-local. And that sets the link local address on the gigabit interface. Now I'll just do an up arrow on my keyboard and hit the backspace, and now let's give it the global unicast address. The global unicast address will be 2001:DB8:DA and :1. This is the first subnet, and :1, he'll be the first address in the first subnet. And we need to also give the network prefix length, so /64. So that sets the two addresses, the two IPv6 addresses that you're going to need on the interface. You need your link local address and you need your global unicast routable address right here. Now all I have to do is type no shut and the interface should be up. Let's configure the rest of our interfaces. So now what I'll do is I'll just do up arrow on my keyboard, and this time we'll do interface serial 0/0/0. Now this is the interface that points towards router R2. So I'm just going to do up arrow. Remember I said it gets the same link local address, so all I need to do is do that, put that in again. And then for the global unicast address, it's going to be 2001:DB8:DA:, and this will be the 2 subnet. And it's also going to be the first address in the 2 subnet. So just hit enter and then no shut, and that brings up the interface. Now, once again, I've got the right subnets here, subnet 1 and subnet 2, but I forgot something. On this second subnet on this interface, we need the clock rate on the interface. So I'll bring this back up, and while I'm still in the interface, I'll just type clock rate 128.0.0.0, and now I'm done with that interface. So now let's talk about the other interface. Now the other interface is slightly different because the subnet has a different addressing scheme. It's 2001:DB8:CD1C, and it's going to be host number 2. So CD1C host number 2. So what I'll do is I'll do up arrow till I get to interface, switch over to 1. Now I'm in serial 0/0/1, and we're going to give it the same link local address, but for the global unicast address, it is CD1:C, is it? CD1:C and host number 2. So 2001:DB8:CD1:C::2, and that should be the right address. No shut. Okay, and you can see that when we activated both of these serial interfaces, they both changed state to down, right? They're not up. We said no shut, turn them on, but they're still in the down state, and that's because the neighboring router on the other end of the link, the interface is shut down. So these interfaces won't come up until the neighboring router brings up their interface so that both interfaces are up. So they're physically, these interfaces are physically up, but they're logically down. So, so we have some more configuring to do. Now, this router, before I leave, is also going to need something, and I might as well just jump ahead and do it now. This router is going to need, let's see here, on R1, configure an IPv6 default route out of the serial 0/0/1 interface. So I'm going to do that right now. IPv6 route : 0/0. This is the equivalent of a quad 0 route in IPv4, : meaning all zeros, /0 for a 0 network prefix length. So this will match all routes. So this will be a default route out of serial 0/0/1, so out of that interface. All right, so now I have a default route. And the last thing, the only thing I'm missing is my RIP commands that I need to set up on the router. And I also want to propagate that default route. So I could jump ahead, and before I'm even done with R2 and R3, and I could say, all right, on R1 and R2, enable RIPng on each interface except R1 serial 0/0/1. So we could jump ahead. I already did. I jumped ahead to step 4 and set up the default route. If I wanted to, I could set up the routing protocol right now on step 3 as well. So I'm going to enable RIPng on each interface except for the interface serial 0/0/1 that heads towards the ISP router. So I'll need to set up RIP on these two interfaces, my gigabit and my serial 0/0, and the name RIP1 in all caps will be the RIPng routing process name. All right, so they can do that. Let's do that right now. So I go back into the router and I'll say interface gigabit 0/0, and I'm going to say IPv6 RIP, and then I'll go a space and then a question mark, and you can see use selected string to identify this RIP process. So that's where we'll put in the string or the name RIP1, and then a space and then a question mark, and you can see we have two choices here, default information or enable. So what we'll do is we'll type enable, and that enables the RIP IPv6 or RIPng routing protocol on that interface. So now I will go to serial 0/0/0 and do the same thing, and just do up arrow to enable the same thing. But I'm also going to say, all right, not only that, I want to distribute out of my serial 0/0/0 interface my default route that goes towards the ISP router. I want to distribute that out of this interface so that the other routers can learn that I have a default route basically to the internet. So I'll do that. I'll say okay, up arrow, and I can back out of this and then put that question mark, and you can see that there was a choice for default dash information. So I'll put that in DEF tab and then a question mark, and you can see there's the originate part of it. So default dash information originate, and that will distribute my default route to the other routers out of the serial /0/0 interface. So I believe I'm all done now with this router. I can just do a Control C and then copy running dash config to startup dash config to save my configuration. I'll hit enter again to accept the default name startup dash config, and I've saved my configuration. Let's do a show run to take a look at our running configuration here. There's my IPv6 unicast dash routing command that enabled IPv6. There's my gigabit 0/0 interface with two IPv6 addresses and RIP version 1 or RIPng with the name RIP1 enabled. And there's my two serial interfaces. You can see one has a clock rate, and there's the default information originate command distributing, and RIP1 is enabled. And I did not need RIPng with the RIP1 name enabled on serial 0/0/1 because the ISP router is not going to be participating in RIPng with me, because the ISP router is theoretically separate from my network or from my organization and all of the routers that I have control over. So I'm just running this dynamic routing protocol in basically my organization theoretically. Okay, so that looks good, and it's time to configure the rest of the routers. So now I need to configure the rest of the routers. I'm going to skip the ISP router and go straight ahead to R2 because we need to run through the same process that we essentially did with R1. So I'll open up R2, go to the command line interface, stretch out the window a little bit here so we can see the commands. I'll hit enter, enable, conf T to get to global config mode, and set the host name of the router first. Okay, so the host name is R2, and now I need to enable IPv6 Unicast-routing. That turns on IPv6. Now we'll go to interface serial 0/0/0, and this is the interface that points towards router R1. Now this interface is not the DCE, so we do not have to set a clock rate. We just need to set our IPv6 addressing. So we'll do the link local address first. And let's see here. Okay, so IPv6 address FE80:2 link-local. Okay, how did I know that? Well, once again, this is R2, and we're talking about R2, and it's going to get the ::2 address on all of its interfaces. So that's where I got that from. So we set that up, and now it's time for the global unicast address. So 2001:DB8:DA:, this is the second subnet, and he's going to be the second host in that subnet, /64 network prefix. How do I know all this? Well, this is the subnet right here, the second subnet, and :1 for this router R1, :2 for this router R2. So that's where I got that from. Then a no shut command, and now the interface is up. Let's take a look. We can see the green lights now on the interfaces, and it looks like it's pretty good. So now let's do the other interfaces. So what I'll do is I'll go up arrow, interface gigabit 0/0. So this is the LAN facing interface. Hit enter, and now we're in that interface. And I'll just do up arrows until I get to FE80::2 and take the same link local address. And then for the global unicast address, this is the third subnet, and he'll be the first host in the third subnet. Then I'll do a no shut command, and you can see that the interface changed state to up. So now it's time for the last address, or the last interface rather, and it's this interface serial 0/0/1 pointing towards R3. But one interesting fact here, this is the DCE. You see the little clock here. So this is the DCE interface, and R3 has the DTE. So we'll need to put a clock rate on this interface. So we'll just run through the commands here. And this is the fourth subnet, and he'll be host 1. Okay, so we'll run through the commands once again. So let's see here. Are we in that interface yet? No, we're not. So we'll say interface serial 0/0/1. We'll set the clock rate. Then we'll do up arrow. There's the link local because it's R2. And then the global unicast address. This will be the fourth subnet. And then the no shut command, and that should be good. Now notice the interface changed state to down as opposed to the gigabit, which went up, and the other serial, which went up, once again because R3's interface is down, and we haven't configured R3 yet, so there's nothing to worry about there. What we do want to do though is we want to enable RIP on all of our interfaces. So before I leave this interface, let's turn on RIP. So we'll say IPv6 RIP, and this is RIPng, not RIP, it's RIPng. So it's the IPv6 version of RIP. Now the name we gave it was RIP1, and then enable. And that turns on the RIPng protocol on that interface, and we need to do the same thing for the other interfaces. So we'll just go into interface serial 0/0/0 and do the same thing, and also to interface gigabit 0/0, and also turn on the RIPng routing protocol and the RIP1 process, which is the name we gave the process. Okay, I'll do a Control-C, show run. Take a look at our configuration and make sure everything looks good. You can see RIP is enabled, and RIP is enabled. Now, if everything has worked correctly, we can take a look now at our IPv6 routing protocol. So show IPv6 route, and you can see that we've learned about the one subnet, IPv6 one subnet from RIPng. So you can see the R here. Look here, and it says R's for RIP. So we learned about the one subnet from router R1, and we've also learned there is a default route out of the network. Let's see here. So you can see here ::/0. Looks like there's a default route that we learned about. So everything is working. We could also go up here to PC2 now and see if we can ping PC1. So I'll go up here and say ping 2001:DBA:1:A. That is the IPv6 address of PC0 down here. Let's see if we can ping him. And you can see we're getting replies. So now, with R1 configured and R2 configured, interfaces up, and RIPng configured, we can communicate between this network all the way over to this network right here. If we look at R1's IPv6 routing table, show IPv6 route, you can see that R1 has learned about the 3 subnet from R2. So we're doing pretty good, and all we have to do now is configure R3 and then the ISP router, and we'll be all done. If we look at our completion rate, let's see here, our activity, you can see that so far we're 68% complete on our configurations. Okay, so let's finish this activity. I'm going to speed through the process of configuring R3 so we can get to the ISP router. So I'll open up R3, and we'll just open this up, stretch it out, and begin configuring here. That turns on Unicast routing and sets the host name, and now we need to do the interfaces. So interface serial 0/0/1, I believe. Let's see, that's correct, and it's not the DCE. And we'll set the IPv6 address for the link local. It's the third router, so it gets FE80::3 and then link-local. Then I'll do an up arrow and we'll set the global unicast address. It's the 4th subnet and the second host in that subnet. We can double check that if we want, but I believe that's correct. It says here incomplete command. What did I forget? I forgot my /64 network prefix length. All right, that looks good. And then a no shut command. Okay, that turns it on. Let's also, while we're here, turn on the RIPng routing protocol. So IPv6. Let me back out of this so you can see the command better. IPv6 RIP, and then RIP1 is the name of the process, and enable. So that looks good. And then once again, subnet 4 host 2, we can always double check that. You can see it's the 4th subnet, host number 2, and this is the interface we just configured. So that looks really good. Time for the gigabit interface. So I'll just do an up arrow and set the, there we go, for the link local, ::3. Once again, you can see right here on the side that R3 gets the ::3 link locals. And then the global unicast will be subnet 5 host 1, and then no shut. And then I also need to give it the rip1 enable command to turn on the RIP routing protocol. So now that's set. So I believe that's all I need to do on that router. I do need to save my configuration, and I'm not positive that I saved the configuration on R2, so I'm going to go back and do that as well. Okay, forgot a space, there we go. Alright, so R3 has been configured now, and all we need to do now is configure the ISP router. Now the ISP router is going to be pretty easy. We just set the host name, turn on the IPv6 routing protocol, and configure this one interface here. It does not run the RIPng routing protocol, but it is going to need a summary route, because that's in the instructions over here, that on the ISP router we need a summary route out of the serial 0/0/1 interface, meaning this interface right here, to reach all of these subnets, the DA:1, the DA:2, the DA:3, the DA:4, and the DA:5, all of these subnets in one summary route. And I'll show you how I'm going to do that. So we'll go into the router, and we'll quickly run through the easy stuff that we've done before. So enable. We have to set the host name too. We're going to set it to ISP, and then IPv6 UNI tab unicast routing interface serial 0/0/1. He is the DCE, so we'll have to set the clock rate. I almost forgot that. There we go. And IPv6 address. Now, for the link local address, let's take a look here. The ISP is going to have a slightly different number for its link local, so it'll be FE80::C. I like to put in the caps there, and then link-local. All right, there it is. And then for the global unicast, 2001:DB8 CD1 let's see here, C, and it's 1. Okay, so C:1/64, and then a no shut command. All right, so now that serial interface is up. Now, it's not going to participate in the RIP routing protocol, RIPng, but it does need that summary route. So we need to have a summary route that summarizes, first let me exit out of here, all of the networks. And I've put that process to create a summary route to summarize all these networks into a document here that we can take a look at. So the first thing you want to do is make a list of the subnets that you want to summarize. And so you can see I wrote out the subnets here that I want to summarize, the 1, the 2, the 3, the 4, and the 5. In step 2, what I've done is taken those subnets and I've decompressed the IPv6. So I've written them out basically in long format. And what I'm interested in is the subnet portion of the hextets. So in IPv6, we call these hextets. In IPv4, they were called octets. Now these are called hextets to show that these are hex characters, right? Each character is a hexadecimal character. And that means that each character or each number is worth 4 bits. So one hex character is the equivalent of 4 bits in binary. So you can see here that what I've done is I've taken this 1, 2, 3, 4th hextet, and I've written all of the 4th hextets in binary down here, and you can see that right here. So 1, 2, 3, 4, and 5. And you can see that that's a 1, that's a 2, that's a 3, that's a 4, and that's a 5. So this portion right here is this character right here. Remember I said that each one of these characters is worth 4 bits in binary, so I can divide them up right here, and you can see how I did that. So there's the 4 characters, and the 4 characters. All right, and we'll just lay that out here so that you can see it nice and easy. So that is a 0001 or 0001, 0002, and all that. And so then to find the summary address, what you do is look for the last common bit, just like you did with IPv4 summary addresses. So if we look for the last common bit, we see it's actually this one right here, 00000. All of these subnets share a 0 in right here, but when you get over 1, these have a 1 here, and so those are not common, right? 00011. So this is the last common bit, and now all we have to do is count over. So we say, okay, this is 4 hex characters, or 16 bits binary. So 16, 32, 48, and now we just count over 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61. So this is the 61st bit, or 61st bit rather, and so the summary address will be 2001:DB8:DA:/61. And what this will do is, since this bit is essentially in the 8's place, right, the 1's place, the 2's place, 4 and 8, this will summarize subnets 0 all the way up to 7. So this would work for subnet right here all the way up. Let's copy that. If we had one, it should summarize all the way up to subnet 7, so that would be a 7. So it'll cover subnets 1, 2, 3, 4, and 5 easily because it goes from 0 all the way up to 7. So that's what we're going to use for our summary address. So we'll go back in to the ISP router here. We're in global configuration mode, and we'll type IPv6 route, and then I'll just paste that in there. So we're going to go to the 2001:DB8:DA:/61 out of the serial 0/0/1 interface, and there is our static route, our summary route. So now the ISP router is finished. We just do a Control-C and a copy run start to save our configuration, and we should be able to ping this interface now from PC1. So I'll go over here to this last PC over here in the network, open up the command prompt, and let's see if we can ping the host. 2001:DB8:, let's see here, which one was it? CD1:C::1. And you can see that I'm able to ping the ISP router. So obviously it's working. The ISP router is able to send the echo reply back to me, so we have communication across the network. I can also look at, let's see here, the PT activity here and check our results. You can see that we got 100% completion on the activity, and if we check the results and go to the assessment items, you can see all of the items and all the configurations that we were able to complete correctly, and we got a 57 out of 57. If you were one of the first people to download this PKA file off my website, the first time I did this, I mistakenly put the summary route as a /60 instead of a /61. So if you were one of those people and you have that early file that I made and you're not getting 100% on the activity, just try changing the summary route from a /61 to a /60, and it'll register 100%. To get rid of the route in Packet Tracer, all you do is put a no in front of the IPv6 route, and that will remove the route from the routing from the configuration file, and then you can put the route in again and instead put a /60.